All right, students. This is 2004, question number 3. Again, Desmos.com, if you don't have a graphing calculator, is a place to go. First thing I did is I typed this right here into my calculator, into Y1. Going to be using some hotkeys. And remember, make sure that's a tan inverse or an arctangent. Okay. So, question number, part A, whatever, is pretty easy. They just want to know what's the acceleration at time 2. Remember, when it comes to dealing with these items, you have position, its derivative velocity, and its derivative acceleration. So those are our 3 different items here. Now notice I used y of t instead of x of t. I could also call position x of t, or I could call it s of t. But when it's moving along the y-axis, it's just moving up and down. I just call it y of t. If it was moving this way, I call it x of t, and I can always just use s of t. But I'm using y of t specifically because it's moving up and down. Something that the AP exam has done in recent years is if something's moving up and down, they'll put a little y right there. So, and it's hard to see right there where v of t, they'll put a little y there, v of y of t. That simply is another way of them telling you where things are at. Alright, so the first question is I want to know the acceleration at time 2. So acceleration at time 2 equals, and all I'm going to do is I want to take the derivative of velocity. Remember, the derivative of velocity gets us to acceleration, and I want to plug in 2. So I'm going to hit Math 8. I'm going to tell my calculator to take the derivative of this equation. I could type the whole equation in here, or I can use my hotkeys since it's already in Y1 and tell it to plug in 2. And if I type this into my calculator, I get about negative 0.132. There's some other decimals. I probably should have kept one more. Oh, whatever. I'll keep one more. I didn't type it in. I just looked offline. That's cheating. All right. Math 8, the derivative of what's in y1, evaluated at 2, which is up. All right, there's a 9 at the end. There you go. Now everybody's happy. All right. That's part A. Part B says at time equals 2 is speed increasing or decreasing. Remember, this is where you need to know velocity and acceleration and see, do they have the same signs or different signs. If velocity and acceleration have the same signs, they're both positive or both negative, speed is increasing. And if they have different signs, one's positive, one's negative, speed is decreasing. Now, sometimes in the past we've made sign charts of velocity and acceleration. And we could use this sign chart to find whole intervals. You know, up in this interval right here, they're both negative, speed's increasing. But we don't need whole intervals here. We only care specifically at time equals 2. So I only need to know the acceleration at time 2, I found that in part A, and velocity at time 2. Now to find velocity at time 2, I'm going to use hotkeys. You could just take a 2, put it right there and you're done, but it's already in Y1 in my calculator. So I'm going to type in Y1, alpha trace, put parentheses, put a 2 there. And that's going to give me the answer that I need. So, let me go to the calculator. So, alpha trace, tell the calculator to plug in a 2. And I get negative 0.4367. And now, just look at these. They're both negative. So, speed is increasing. So, again, I would say at time equals 2, speed is increasing because, and you better mention velocity, velocity and acceleration are both positive. Come on, probably get not both positive, they're both negative. I could say are both negative, or because velocity and acceleration have the same signs. Please note that you can't say they have the same signs unless you have told them somewhere what those values actually are. I've told them what these are. So now anyone could look and say, yep, they're both negative, same signs, yeah, you're right. Okay, let's go to part C. For time greater than or equal to 0, at which point does the particle hit its highest point? All right, so this question, at which time does it reach its highest point, is actually much easier than one would think. So what I did is I went and graphed velocity, and I zoomed in a little bit because I needed to see what's going on. From far away, the graph looks like this. And it looks like it crosses through 0. I zoomed in just a little bit. And the graph now does this. Now, a couple things. First of all, we're only using this when time is greater than 0. So I don't need anything over here. And if you look at the graph, it's positive. This is, again, my velocity graph. It's positive until I reach here, and then it's negative everywhere else. Okay. Now, I'm going to find that point. That's very important. When is velocity equal to 0? And we're going to make a sign chart of velocity, and then we'll talk about it. So I'm going to hit second calc 0. I go to the left, I go to the right, I hit enter, and I get 0.4430. Okay, so let's look at my sign chart for velocity. This is 0, this is 0.4430, and you'll notice velocity is above the curve, positive values, and then negative values. Now, a couple things. Normally when velocity is positive, we would say the particle is moving to the right. But here, remember, it's not moving left and right, it's moving up or down. So this would normally mean going to the right, and then this would mean going to the left. Well, instead, this now means it's going up, and this means it's going down. So, if I was tracking this particle here, if a particle went up, and then down, it went up, all positive, and then down, negative. Now this thing down here stays negative forever. If you want to keep moving the graph out, it's always negative. So if a graph goes up and then down, and it goes down forever, not only is this a relative maximum height, it is the absolute maximum height. So I actually don't have to do anything else. Sometimes I'd have to check endpoints and critical points. If you make a quick sign chart and you ever get something where there's only one change in direction, then that means that you don't just have a relative max, you have an absolute max. Just like the graph of x squared, negative slopes, positive slopes, that's not just a relative minimum, that's an absolute minimum. The graph of negative x squared, that's an absolute maximum, not just a relative maximum. So same idea here. So I could say it reaches a maximum height at time equals, I'm going to sneeze. Do you see the elbow right there? Corona block. Anyways, so at time equals 4430 because velocity was positive from, and I want to make sure they know it was positive this whole time. So it was positive from 0 to, this is a fancy way of saying, in between these two numbers, and it was negative from, and we're just going to say from this 0.4430 number to infinity. Or there's other ways of writing it. I could have said, the parentheses 0 to 0.4430, like intervals, and 0.4430 to infinity. But anyways, maximum height because velocity was positive, and then negative. So it was always increasing height until here, and then it was decreasing height. So that relative minimum was actually an absolute minimum. All right, let's go to part D. Part D says, find the position of the particle at time equals 2. Now, not all things are now on the AP exam. So this next part we're about ready to do, not on the AP exam. We're still going to do it because, well, you're going to do more calculus in your life, or physics. So you're going to need this. So just a quick, easy thing is if you want to know a particle's final position, remember, final is the initial and then plus the area underneath velocity. Remember, the area underneath velocity gives the net change in position. So you're driving on 95. Have you heard this story before? You drove 45 miles. Where are you at? We don't know. You need to know where did you start plus how much should things change. So if I want to know where is my particle at time equals 2, I need to know where it was at some time. And if you read what's in here in the blue book, it says at time equals 0, the particle's position is -1. Now, normally I would write time equals 0 like that, but we're going to write y as 0 because it's on the y-axis. Okay, so in this problem right here, I want to know where's the particle's position at time equals 2. I know the particle's position at time equals 0. Plus, and again, the area underneath velocity, I need to know how much did the particle's position change from time 0 to time 2. When I go to type this into my calculator, I'm going to do -1, because they told me at time 0 the particle's at -1. So -1 plus this. And if I type this in, I'm going to find out where's the particle at time 2. So I type in -1 plus math 9. I'm going to integrate from 0 to 2 of what's in y1. And I get the particle's position is at time, or is at, sorry, at the position -136, so -1.3606. Okay. Then they ask a second question. Is the particle moving towards the origin or away from the origin? Okay. So here's where we got some thinking to do. We're going to keep this sign chart of velocity. It's going to be helpful. Remember, in this situation, the particle is moving up and down on the y-axis, and right here in the middle is 0. Okay, there are 4 scenarios. At time equals 2, we already know where the particle's at. I can answer the question right now, but I'm going to have you wait. Let's say the particle is here. Let's say at time equals 2, the particle was here. Do you guys see how the particle could be above the origin? So right now, what if y2 was positive? Well, is it moving towards or away from the origin? Well, that matters. What matters is it moving up or down? If it's going up, well, what tells me something is going up? Well, something would be going up if the velocity is positive. So, let's look at this. At time equals 2, if, now this is not accurate, but if my particle had a positive, if the position was positive, which it's not, if the position was positive and the particle was moving up, then these two ideas would make it go away from the origin. It's above the origin, moving up. Well, that's the first scenario. The second scenario is that the velocity could have been negative and the position is still positive. So the position is positive, it's above the origin, but if the velocity was negative, this time it would be moving down. If it starts above the origin but it's heading down, it means it's heading towards the origin. So if it's above the origin, heading down, it's heading towards the origin. And then these two ideas get repeated down here. So down here, if my particle is down here, its position would be negative. So if y2 is negative, meaning it's below the origin, and my velocity is positive, velocity being positive would mean it's moving up. So if it's below the origin, moving up, it would be moving towards. But let's look at the other scenario. What if, again, my position is negative, but my velocity is also negative? Well, negative position means it's below the origin, and negative velocity means moving down. Well, if you're below the origin, moving down, then that means it's moving away. So these are the 4 scenarios you can have. Mr. Puckett, do I have to memorize all this? No. You think, where's my particle at and which direction is it heading? So, quick little number line, put it somewhere on there, decide if it's going up or down, and you can kind of use common sense. 2 things are important to know if you're heading towards the origin. Where are you at? Are you above or below? That's going to depend on position. And then which direction are you heading, up or down? And that's going to depend on your velocity. So if we go back to the information we found, we know that y2 is negative. So we're in one of these scenarios down here. And then in part B, we found out that velocity at time 2, if you guys go back and look at that number, was negative. I have down negative 0.436. Okay. So both position and velocity were negative. So it's going to be moving, it's this scenario, so it's moving away. So again, I would just say, for this problem, I would say, at time equals 2, the position is this, the velocity is this. So I would say that the particle is below the origin, moving down. So it's below the origin, moving down, therefore moving it away from the origin. So, strange question. It's not the hardest thing in the world, but you have definitely not seen it. So, hopefully you watched this video and it made sense. And that's it. That's the 3rd video for today. Have a great day.